We're asked to solve the following system by using the elimination method. Now, what does elimination mean? Well, elimination means, cancel, to get rid of. So what we're going to do is we're going to try to eliminate or cancel one of the variables, either x or y. Now, in order to do this, we need to get the variables to be equal but opposite. What I mean by that is, if you had 2, what would be equal and opposite of 2? -2, so that it would cancel out properly. Okay? So what I'm going to do here is I'm going to look and see, okay, I have x, I have 5x, I have 7y, I have 6y. The easiest thing to do here is to try to eliminate x, because I've got a 5x in the bottom, and the top I've got an x. What would get rid of a 5x? A -5x. So what I'm going to do is I'm going to multiply this top row here by a -5, and that looks like a weird number. Let me erase it. There you go. That looks more like a 5. -5. Okay. So we've got -5, and then we're going to end up distributing all the way across. And this is what a lot of students will forget, is to distribute all the way across. So let's go ahead and distribute. We get -5x minus 35y equals -45. Okay. And then the second row, we didn't touch it all, but we're going to copy and paste, as I say. 5x plus 6y equals 16. Now what we're going to do is we're going to combine the two rows through addition. Alright, so -5x plus 5x, that cancels, and that's what we were hoping for. And then we have -35y plus 6y, so that gives us there -29y equals, and then -45 plus 16 happens to be -29 as well. Okay, so then our last step to solve for y in this case is to divide by -29. And we end up with y equals a +1. And then I'm going to go ahead and circle that for right now. And now that I know what y equals, well, I'm going to take that and plug it into one of the original equations and solve for x. So let me go ahead and do that. Let's say I'm going to take x, and let me take that back. Here we go. X plus 7 times y, which is 1, equals 9. So I'm using the very first equation here, x plus 7y equals 9. And in there, right here where y is, I'm going to plug in y equals 1. And so that's how I'm going to solve this one. Okay. So now 7 times 1 is 7. So x plus 7 equals 9. And then subtract 7. And then I end up with x equals 2. So here is my ordered pair then. Alright, so here's right there. The ordered pair for this being 2, 1. So this system has one solution, and it is 2, 1. So this is where they intersect. So let's go ahead and take a look at one more example using the elimination method. Here, what if I had 6x plus 5y equals 7, and 12x plus 10y equals 5. Well, I know that it's probably fairly simple to get equal and opposite here, because I've got a 6, I've got a 12, I've got a 5, I've got a 10. So I could probably just multiply by, suppose the top, a -2, so that I can get opposite, and then I'll get equal right after. So let's see here. I'm going to get -12x, I'm going to get -10y, and I'm going to get equals -14. And then in the bottom, that didn't change, 12x plus 10y equals 5. Now just a note here that it may be necessary to multiply both the top and the bottom row by a number to get equal and opposite, but just keep in mind what we're doing, and it's fairly simple to solve. So then we have negative 12x plus 12x, that cancels. And coincidentally, we also have negative 10 plus 10, and that also cancels. And we're left with 0 equals, and then on this side, negative 9, which we know this is actually not true. 0 could never equal negative 9. So this one right here, this system, is said to have no solution. Alright, this one is said to have no solution. You may also see, depending on what book you're using or if you're using any kind of online software, whenever you get a false statement like this, they may also say the solution is the empty set. So they might indicate that with the null operator there, the null symbol, that there is no solution, because we end up here with what's called a false statement. So there is also the possibility that you may end up with a true statement, where you may end up with like the variables canceling and you get 2 equals 2. That's a true statement. That's actually the case where you have infinitely many solutions. So just keep those things in mind as you're solving systems of equations.